Oh, hello everyone, and welcome to the AWS webinar where we are going to talk about how the University of Oxford took its museums collections into the cloud. And today we have two speakers which we are introducing together with Collections Online. So you can see the link to the collections and the things that we are going to speak about. So it might be useful to click on that link, which will be showed now in the chat mode. And in the chat where you can see how the collections look like. You can also hit some questions to the query, and then you can also later on ask our speakers if you have any questions on how this works. And before starting, I would like to introduce Peter Jackson. Pete, would you like to introduce yourself and the Cyrus HQ?
Yeah, good morning, everyone. I'm Pete Jackson. I'm a business architect at Cirrus HQ. I've been working in the education sector for nearly 20 years, developing solutions for everything from reception through to primary, secondary, on to further education and higher education. And at Cirrus HQ, well, we're just really friendly, and we are a advanced AWS partner, consulting partner, and our friendly nature is important because our tools are our people, and we help support your journeys to the cloud, in particular AWS, which is our main focus. So we help migrate, build, design, deploy, manage, and support your workloads in the cloud. And I think that should be a nice little update for me. You might be on mute, Daniel.
Now moving to Anjanesh Babu, who is our system architect and network manager at Oxford Gardens and Museums. So Anjanesh, back to you.
Thank you, Daniel. Thank you, Pete. Good morning, everyone, and good evening, good afternoon, wherever you are from. And thank you for being on the webinar. It's really encouraging to see the response. My name is Anjanesh Babu. I work as a systems architect and network manager for Gardens and Museums. We are a division within the Gardens Libraries and Museums within the University of Oxford. I think we will explain this a bit more. I've been with the university for the past 10 years, started my role as an IT support officer, and currently I'm a systems architect network manager. Fairly new to cloud, last 5 years, and then actual workloads has been 3 years. I have been with Amazon workloads for the last 2.5, 3 years. I'm a huge fan of Amazon and cloud in general. I look after the infrastructure across Gardens and Museums. We have a small team of 7 where we work with service desk and networks and web. We also work with external partners like Cirrus HQ, who are vital to our core delivery strategy.
Cool, thanks Anjanesh. And before we dive deeper into the topic, I would like also to introduce AWS as a platform. And AWS is the most mature cloud platform out there currently. As we internally like to say, there is absolutely no compression algorithm for experience, especially when it comes to scale, security, and performance. And by saying that, we can also fairly say that education is built on AWS. And you can see number of education institutions starting from edtechs, publishers, different online platforms, all the way to the top universities like Oxford are using AWS to support their critical infrastructure, to support the students, the learning processes, and institutions at all. Currently, we have hundreds of millions of students who are using content on top of AWS in 200 territories across the world. 19 out of 20 well-funded US technology startups are using AWS, and this includes Civitas, Coursera, Echo 360, Schoology, and Schoology. From the research perspective, 96% of R1 research institutions are using AWS for their research workloads, and this includes Cornell University, Arizona State University, and University of Notre Dame. And one thing that we will be discussing today is how Cyrus HQ as a AWS consulting partner helped Oxford to start their project with AWS in the cloud. And this is something that we are also offering a similar experience or a start of a similar experience, which we call a courtesy onboard program, which helps the institutions like you to help you to start your journey in AWS cloud. Partners like Cyrus HQ are able to provide you with a courtesy onboard workshop, which contains out of one of predefined workshops. So you can look into developing a public website, for example, or setting up an instance of learning management system, and virtual desktops and labs, for example, or one of the storage gateway workloads to manage your storage. And now in the discussion, we will actually portray and show how this was, how similar experience was done together with Oxford. So without further ado, I will give the floor to Anjanesh and to Pete to get you introduced to GLAM project.
Thank you, Daniel. So I thought it'll be useful to give an introduction to University of Oxford. It's highly federated and evolved. Just to give an idea of where we are, so within the University of Oxford, there are several divisions, one of which is the gardens, libraries, and museums. We are responsible for the public-facing, the heritage side of the university, the GLAM. So the GLAM comprises of all the divisions you can see on the screen now. So the Ashmolean Museum is the oldest UK museum, established in 1683, and possibly in the world. So we have no challenges for that. And we've got Oxford Botanic Gardens and Harcourt Arboretum. These encompass about 400 years of botanic collections, and they're spread across 2 different sites. Oxford University Museum of Natural History. If you're looking for dinosaurs in Oxford, come to us. We've got the Bodleian Libraries, which is the biggest library in the UK. Petrus Museum of Art and Archaeology is again a fantastic collection of different cultural artifacts across the world. And History of Science Museum has got, again, a huge collection of historic instruments, which is coincidentally also the building where the Ashmolean was originally set up. So for today's discussion, I work with the gardens and museums, which means basically not the Bodleian libraries, and the context is all framed in this slide. All the museums, thank you. All the museums have got unique collections, and we can probably display anywhere between 1% to 5% of our collections at any one point. It is a constant requirement for us to go through the collections, make sure we can display them either online or on premise. And we get about roughly, I was looking at the stats, we get about 2.3 million visitors across all our sites every year, physical visitors. And we get about 2.9, maybe 3 million website visitors across all our sites again. So the fundamental requirement for any museum across the world or heritage collection is a collections database, which in the next slide we can sort of summarize what different collections management looks like. So starting from your left and going down, going to the right, we have an internal staff on their laptop working with an app that interrogates a database and a folder with media files. This is fundamentally any collections management system, at least the ones I've looked at, we've got in-house, would comprise of these systems. So any photographs, any media is stored in a folder, and you've got a database, which is MySQL, TigExpress, depending on the collection, it could be Microsoft SQL. That is fundamentally the core of any collections application. It's so when a user or a staff member looks at it from the left, the database is matched up with the media and it's presented, and we can add media, change database. So this is internal. The blue square is Oxford. It's internal to the university. The green square on the top is a web app, which is usually completely independent of the on-premise collections management system, and the data is exported. It's almost like a surrogate. So you have a mini-me version of the on-premise collection, which is exported and available online, and the user visits online. The reason why the difference is primarily because we can't display all our objects online. Maybe they're not in good shape to be displayed online. Maybe we don't have the copyright. There might be sensitivities around this. So there's a huge curatorial process before collections are made available online. And I can, on the next slides, we can give you an idea. So all of these are existing collections. So the Ashmole Museum, if you want to have a look, has got that particular web link. Again, it operates a similar architecture behind the scenes. There's two distinct, and they're looked after the Ashmole Digital Collections team, and they do a fantastic job of bringing the data from on-premise databases onto the web app. The next museum to look at is on the next slide, we can look at the Pitt Rivers Museum. The Pitt Rivers Museum has got a similar design. We've got the web presentation on a separate server. The architecture behind Pitt Rivers is completely different. It's working on an Apple FileMaker server. It is probably one of the most well-designed databases, because from the ground up, it has designed a web interface and it works phenomenally. So please feel free to explore these web databases. These are all current databases. So on the next slide, we can look at another museum, which is the History of Science Museum. The History of Science Museum uses a collection management system called EMU, which is built by Axial. Again, a brilliant product which works with the collections. So two of our museums use the same application, which is the Axial EMU. And the last slide in this category is the online collections. This is the final product of the project. This is what the conversation is all about. This is the direction that we are taking. And on the next slide, we will have the details. So this is for the Natural History Museum, which is what we are discussing. It's broadly, we can classify the services and the components from left to right as a summary of monolith applications. From the left, you have the staff user. They access the EMU app server using a Windows client. And the EMU API, which is running on the same server, is pushing data to a standardized LAMP service on University IT Services. University IT Services run a platform, web server platform, which you can use, which we use the PHP MySQL part, and it does the same thing, integrates the core server, brings the data onto the web user. This was the historic, the legacy solution. This is basically addressing the why, and this brings on to the Amazon. What's the journey with Amazon? We've been having discussions with Amazon since 2015. So in 2013, we internally had discussions. Let's look at the cloud thing. And 2015 onwards, we had discussions with Pradi and the team at Amazon, who were fantastic. They knew that we were not jumping into Amazon solutions right at the point, but there was a long haul, and that evolved in 2017 when we looked at an active project to consolidate. So the project was to look at infrastructure. So all infrastructure was changing across gardens and museums. It's a huge investment, but then we need somewhere to safeguard all our collections, all the media assets. The design at that point looked at S3 versus traditional storage. What do we do? So we couldn't commission storage quick enough to get everything off. So the attractive solution was go with public cloud, and Amazon was the default choice here. So we uploaded about 60 to 80 terabytes of data within a month using different combination of Amazon Snowball and storage gateways and different, we had clients running on. So that was a massive exercise, and it was successfully complete in a month. And we still have similar amount of data backed up. And from there, when we looked at long-term strategy, this particular project, which is looking at online collections. So as you see in the previous few slides, the online collections were quite fragmented. So as a user, you may not need to know. You're probably interested in a samurai armor from a museum. You don't really maybe not care which museum it's coming from. So this is where the whole strategic requirement was lying. Let's bring everything together. How do you make it more modular, and how do you repeat? How do you make it more exposed? Because at this point, we're looking at traditional architectures where we're looking at single points of failure, whether it's with people, technology, or servers. And the two options we looked at that point, Pete can explain in a bit more detail, was whether we look at containers, whether we look at serverless. And serverless was the option to go with. Pete, do you want to step in and explain a bit why we had the decision point?
Yeah, absolutely. So yeah, we joined around the 2018-2019 mark, working with Anjanesh's team. So one of the first critical decisions and the options that we looked at with the team was their evolution to serverless technology, and there was a really strong applications development team at within the university, and they were evangelized already to break down their components into their salient functions. So they've already broken down each call to the museum database into its own function. So therefore, in itself is a microservice. So it, and the other really important point on this is that Anjanesh himself wanted to build a lightweight solution in the cloud and then build out from a solid set of services from that. So given those two elements, Lambda was the chosen delivery tool for this. Lambda is absolutely fantastic. It means that you only pay for what you invoke, so what you run at the time of when it's needed. You can break it down and hold each of those functions into a separate Lambda function. And we literally can deploy, and all the management around the operating systems, things like that are taken away. We just need to know that we can run that at the time. We looked at Docker, which is the other one that Anjanesh alluded to, but for the proof of concept and the pilot for this particular project, the very much the option and direction of travel was to use Lambda. I think it was just a little bit more known and controlled within the university. Is that fair, Anjanesh?
That's a fair summary. Thank you, Pete. That's a really good summary. What I should also mention is the project team itself. We had a brilliant project team. We have a brilliant project team led by the project manager, Marcus Cheatham, business analyst, Karen Ward. And we've got fantastic developers working in IT services, Marcos, Finlay, and John. All of them came together. So we were already working in a distributed fashion. We knew we could pull this together, but we didn't have the resource. We didn't have the expert leadership to get along. We got the high level functions right. This is where we started looking for partners, and we actively, Amazon were brilliant, our solution architects like Pradi and our account manager, Nick Jefferson, everybody was coming together saying, let's do this. And then we were looking at the resource skill set. We've got a fairly new team. We've got, as I mentioned, there's two different distinct teams, the project team and the BAU operational team. The operational team is fairly new and very innovative on the service side. So we're looking for a long-term strategy to say, we need to upskill our team, but we also need somebody alongside with us to guide us and shape where we go from here. Because projects operate in sort of sprints of a year or two, and then they go away. But then we are left with the service which we need to make sure we can contain and we can sustain, and we can also fund at the same time. It is really crucial. So we worked with we explored a few options, and with Cirrus HQ, I think what stood out was they didn't know the answers. They were very good at the expert, but they had the confidence to find the answers collectively, and that's what we do internally as well. So we do proof of concept, we do pilots, and we can break it down. And then and in terms of the project team and internal teams, we work together, catching up on a weekly basis, mid-weekly basis, and trying to go, right, this is what we did. And some of the things we sort of left behind saying, okay, this is probably not the way to go. And what we need to look at is the traditional app architecture, the EMU server was still on premise. So we still had to synchronize these bits with Amazon. The front end, so we had 3 different parts working for the whole solution. The Oxford University has got a service called Mosaic. It's built on Drupal, and it is hosted by Acquia at the far end. That is the standard web CMS platform. So we had to integrate the web CMS with the front end of Amazon, within the front end of Amazon, and the back end. So this was a huge challenge, and it has been done before in the university. And we had to learn a lot of things together with SearchHQ, with internal IT services teams, with the service desk team, and our internal digital teams. I think it was the very first time we actually worked with. And I might be jumping ahead to the success of this project. The project was led so successfully because the pilot simply rolled over to production. So we didn't have to do anything. The pilot was very successful, and all credit to Marcus and his team for actually leading the project to success and bring the stakeholders together. So just to complete the timeline, so there's other bits along the timeline. So 2020, we are looking at migrating all the servers which are on premise. So we've got backend servers working on premise. 2019, from 2017, 2018, we had a cloud-first approach. 2019 and onwards, we have a cloud-only approach. So we don't consider anything else. So that's the rationale as we go forward. On the next slides, this is breaking down into constituent components. So I'll explain the business internal architecture that Pete can follow up perhaps with the detailed technical bits.
Sure.
Thank you. So as with any technology, you've got presentation, logic tier, and with the attribution below. The left-hand side, we've got the Node.js working with calling Lambda functions. And once in the logic tier, we've got Elasticsearch within Amazon, again using Lambda functions. The data tier is still on premise. So we've got the going back to the first few slides, we have got the images and the database with the data export in XML format, which is taken into an S3 bucket. As you go to the right, we look at the S3 bucket, and that data S3 bucket is already public, then it's processed within the Elasticsearch index in Amazon. And the front end, the presentation goes back to presentation tier, which is the Oxford Mosaic. So all the links that were presented on the second slide is actually Oxford Mosaic. And anytime you use the technology, that's where we go from here. So Pete, do you want to take over this one, please?
Yeah, sure. So I thought it'd be a nice way to illustrate the infrastructure by demonstrating it via a journey. So if you're actually on the page, you'll see a search box of which you can actually have multiple advanced searches from that. But let's take a very simple search. That creates an API call, and this is the thing that first hits the Amazon environments where we have built the collections online solution. We have a secure perimeter for it to ensure that the obvious denials of service and things like that are mitigated, and there's no brute force entry to the application behind it. Then it goes to an API gateway, a very important building block in this. It ensures that the load is spread against all the lambdas and all the calls, and the responses to those calls go to the right place. So vital building block, and I think we'll be coming back to that later. After that, each of those functions are kept in something called AWS Lambda. So the development teams have got each of those different search calls into each one of those lambdas, and then those lambdas interrogate a purpose-built service from Amazon in Elasticsearch as a highly available clustered database, perfect built for searching. And then if you quickly go on a slide, you can see the magic happen going the other way. He says, hopefully, where once that's all happened, then the responses and the assets are then sent back to the Mosaic application, and you can see the results, and you can drill down and look at the nice images of them and all the other wonderful things about them. We've timed this in terms of a performance, and across the 500,000 records that are currently in the database for you to search on, the typical response times is about 0.15 seconds. And again, as we future-proof, we will look into how we can improve that as well. So yeah, that's the application, Anjanesh.
Thank you. And this is basically the code pipeline and the code. This was a very, very innovative method. So we had to learn GitHub either from an architectural use case or from development use case. And we had to work together. We had to build teams on GitHub, which uses SAML integration with our main Azure directory. This was phenomenally groundbreaking because we use GitHub for infrastructure as code, and we use GitHub. The developers and IT services also use GitHub for the Mosaic development. So it all tied in nicely, and because of the GitHub integration with our Office 365, there's no need of adding extra accounts at our end, and it is fast becoming a very favorite tool of choice. I personally didn't have much knowledge of GitHub, and we went through step workshops with Cirrus HQ on the whole process. So, Cirrus, sorry, Pete, do you want to have a
Yeah, absolutely. So it was putting the right tools to the right person within the team, the right people within the team, and it was very clear that the development team needed to be absolutely in control of the flow of getting their getting their implementation and getting that software into AWS. And we wanted to merge with the tool sets that are already being used. So I think it was the development team there certainly evangelized in utilizing Git and GitHub. And this is really, really important. So I'm going to take a particular example. So the development team might be doing some development tasks, and they might have a development branch for that, and then they can trigger that development branch, and that then triggers what we have built for the team, which is basically a continuous integration and continuous deployment development pipeline utilizing AWS pipeline and code pipeline itself. This means that the code is in a code format already, so the deployment is then built, and then the code is then deployed on top of the environment that I've just described as well, which means that, and this is done automatically as well, so end to end. So the developer triggers GitHub to say, yep, I'm ready to do my deployment. Then the pipeline is then automatically triggered, automates the build, and then they get their environment at the end of it, which they can test. It means that testing cycles, improvements are much more in the control of the entire project team. So not just the developers, but the project manager and the business analysts that are approving those kind of changes and things like that. So it really is powerful. And then the same is for production as well, but there's a few extra controls on that. So yeah, so really, really important we put the right tools to the right people.
That was very helpful. Thank you. The main crux was discussions where we've got two environments, dev environment and the product environment. There was talk about the blue-green aspects. Pete, would you like to explain? I keep losing.
Yeah, absolutely. So to make sure we're deploying to production. So there's a couple of things in production. Wait a second. So when deploying to production, we wanted to make sure that it's a controlled environment. We want to protect the brand, and we want to ensure that it was available. So first of all, in the code pipeline, we put in a manual step before, after everything was built. We then put a manual step in where a person from Cirrus HQ would check the build, and it is approved and says what it's intended to do from the development team. If that is in sync, then we would allow that to production. If not, then we would reject the build, and then it would go back, and we would make any changes where necessary. And those builds are typically on a known cadence with the university because they know when the deployment happens. So that's typically, I think, on a Tuesday morning. Then the other part of that is the actual the idea of the blue-green deployment, and we didn't actually do a blue-green traditional deployment. The complications came when updating the data or updating the schema of the data to the Elasticsearch database. Now, typically what would happen is that your data would reside in situ in the environment as well, the data store and the source of data. However, as Anjanesh said previously, the EMU database was still on premise. So therefore, any updates to the schema to Elasticsearch needed to be updated in real time. So what we did, and that can take a long time with schema changes. So what we did is, when those happened, the current Elasticsearch database would still be running, and when we would build a new Elasticsearch database alongside it, when that was built and ready to be populated, we then just basically pointed in a classic traditional blue-green sense at the new database to ensure that there was no downtime and the data was there when ready, when we were ready to commit it to it. So that's where that kind of concept came in. So yeah, there you go, Anjesh. That's the update.
Thank you. And is that where we use Route 53 with the API gateway to for the front end to work with?
Exactly that. We control it all ourselves, so we're in the masters of our own destiny in terms of the pointing and the timing of that pointing as well. Yeah.
Cool. So there's also we had to look at a few things, security in terms of the data security. So anything that's pushed to the online platform is public information. So we had no concerns about data being not the wrong data. The main concerns were about the wrong data being published, or if there's a compromise in the data itself from on-premise. So we correct me if I'm wrong, Pete. We also take snapshots of the S3 bucket once it's on Amazon, isn't it?
Yeah. So there's there's a couple of things here. So yes, we absolutely do that. So because again, if with Elasticsearch it's highly available, if there's any issues with that service or availability or updates, you would basically then take your data from the source and then update it. Again, that source is outside of AWS. So we had the complication, and this is where we absolutely had a meeting of minds, as Anjanesh highlighted previously, to problem solve what was the best way of solving this problem for the university. And we brought in the AWS solution architect in Pradi, who you rightly said is excellent, to help us in understanding how best to take snapshots of the Elasticsearch, retain those for a agreed retention period, and then we utilized actually Lambda again to be able to take those snapshots at the cadence that we wanted, and also then be able to restore that snapshot utilizing Lambda to the Elasticsearch if there was any degradation in the service. So we already knew that the service availability was incredibly high with the tolerance already built into Elasticsearch itself. So this was really belts and braces and protection of brand on top of that solution as well. And then finally, with the Elasticsearch as well, we actually have that separated into its own security group, because even though it's public data, we didn't want anybody to brute force their way into the Elasticsearch and gain access to Kibana and do writes and things like that to the database. So that is, as you already saw, it's behind a WAF, but we also put it in its own separate security group inside a virtual private cloud as well. So it's highly secure.
Yeah, thank you. I think these things were very important because the service part was really, really crucial for us because, so this particular slide shows the journey of the data and how it ends up, sorry, the one before, Daniel. The previous slide shows the journey of so from our collections, the collection manager exports the data. We can also automate it. So there is an automation script involved, which we can do. But at this point, the exports are few and far between, that it is a manual process, and we're happy with the solution here. It goes to the collection manager logs into the on-premise solution and exports the data onto a local folder, and using S3 sync, it's pushed to an Amazon bucket, which is where the rest of the magic happens in terms of populating the Elasticsearch index, or whether adding it to the S3 bucket, which is the media assets. I believe we've had struggles with the on-premise collection solution because of the age of the server and how we had to do a bit of interesting work to make that happen. But on the whole, it's really transparent. One of the decision points we had to make was, do we use S3 sync, or do we use something like data sync, and do we use file gateway? But the simplest common factor was just workable solution was S3 CLI, and using Amazon CLI, the S3 sync just worked out of the box.
It was really important to include the collections manager there, wasn't it? Because it was definitely putting the right, again, it's getting the right tool for the right person, and we were understanding like how often their cadence for updating the online solution from your, you know, your on-premise main source of truth.
Yeah.
So it was a case of getting the right solution for them.
Yep, that's absolutely right. I think the whole process starts and ends with the business lead on this. There's no IT involvement. There's no other requirement. It triggers the whole. This is the data pipeline, which is automated in its own way and reversible as well. So it's quite a nice solution and repeatable and modular, which fits the larger architectural solution. From current, where do we go from here? The future state is coming along. As we mentioned, the pilot was so successful. The efforts of the project team led by Marcus were really, really brilliant in the sense that we just simply rolled out to production. That is one museum out of the rest. So we have completed at the moment one museum. We are looking at all the other museums in a phased manner. So because there's 3 distinct teams we are working right now, we're taking a breather. The project was finished in, I believe it was like 3 months from start to finish. And right now we're looking at resource. So right now we're looking at resource availability across the museums, the IT services, and the project team, where we can roll out the same architecture, the same modular components across the board. Pete, do you want to explain about this diagram a bit more on what the future is like?
Well, it's yeah, I think we were discussing the other day. We basically the idea is the solution itself is scalable. The fundamentals here is that API gateway. It is a kind of always says what it is on the tin. It is a gateway to that solution, and therefore it's extendable. And we know that we've spoken with Anjanesh and others with the university around integrating with Alexa or mobile apps or a number of other places where we can expose that data now for researchers or for anybody that's just looking to explore the wonderful collections that the Oxford has. So yeah, we've basically got a very extendable solution, really.
I think putting the API gateway was really key, because what you see online is just a wrapper. So we don't it's important, but future, we don't know what's coming along. So in the next slide, it's more of the business side of how. The reason I put the slide back in is because at the bottom, you see the database and the folder where we've got the media. Everything is going to be deconstructed. In the next year or 2, we are looking at a solution provider for the digital asset management, and we're looking for different CMS providers, so collections management systems. And at the top in the green square, we still have the online collections platform, which we've now built. So we're not looking at the blue box anymore. So we've got data spread across multiple suppliers, and we've got data consumers spread across multiple endpoints, which brings API gateway into much more sharper focus. And that is the most single point which we've been really innovative about, saying that works. And that really, on the next slide, it sort of gives the larger scale picture. So if you've got the API gateway in the middle, you can interface with Oxford Mosaic, which is the online platform which the university has built, and it just looks at the Node.js code and brings them the data. You can interface with the collections management system, which will be required in the next year or 2. Again, it will be a different service provider. So how do we look at their APIs to pull the data from our APIs? Similarly, we will have digital asset management systems, which will be a different service provider. And again, it's no longer on-premise. All of this used to be on-premise in the same server. It's no longer that case anymore. At the bottom, we may have a picture library, which we will be using for commercial gains. And as museums, I should have mentioned at the beginning, we are free. Botanic gardens, yes, there's a small charge to it, but museums are free. So where's the revenue coming from? So we'll be engaged in research, we are engaged in education with schools, and anything that we can gain a bit of commercial benefit of to put it back into what we do best, serve the public, is always going to be there. So that bit is also important for us. Mobile apps, we don't need to re-engineer the whole solution. Build an API front end, and that's it. And at the top right corner, we don't know what's coming along in future. So it could be that we would be interfacing with another museum collections API gateway. So we could have the gateway to gateway comms on that. This is where the scalability and the modularity of the whole, and API gateway with the WAF almost is a crumple zone as well. So if something does happen, the rest of the assets are well protected. Not that it is likely to happen because we've got so many layers of controls which we can't discuss in detail here, but it's all standard architecture practice. So,
and in fact, actually, going on from that as well, just at because we have built the solution from a very scaled back approach. It's just kind of like the right building blocks at the right time. We already know that for the next iterations and things like that, we'll be looking at utilizing the CDN, the cloud front, and we will be looking at caching at the API gateway level as well. We actually foresee those performance times actually dropping even further, and actually so when we add even more data, will actually our performance times will actually improve because of those just right build-ons to the solution at the right time for the university and for this solution to scale as appropriate. So yeah, absolutely, it's a very exciting base to build on.
Yep, absolutely. I think the whole concept of working with the project, SearchHQ, the partners in IT services, and our teams has been like, we have deconstructed the whole project, different parts, whether we look at the code pipeline, whether we look at the data pipeline infrastructure. These are formed templates. So over the past 6 months to a year, we've built other services. So for example, the backend for the emus is moving to the cloud. We've already moved the backend from one museum. We're looking at the backend for the other museum. So for example, one or two of the other museums will be migrated to another service provider, which will have different services. So there's quite a lot coming along, and it's a very exciting place to be. It's a very exciting place to work, and I think we're fortunate in the position we are in that a pilot project in its infancy was just rolled over to production without actually anyone noticing it, and that explains a lot. I think that states that in itself is a proof of how successful this has been, which shouldn't have been possible without support of searchHQ, with Amazon Solution Architect, with our internal teams, our service desk. So I think that's mostly it from me. Thank you.
This sounds pretty interesting, gentlemen. And I was just wondering if you can share some information on how do you manage the costs of that kind of a project, and how do you look into the future of cost optimization?
Thank you. So initially, one of the main reasons we engage with searchHQ is I call them Amazon Calculator Plus, because it's always there. Amazon Calculator is always there, but sometimes in a hurry, it's not easiest for me to interpret and in a real world situation. So if I go to searchHQ and I tell them, okay, we need this XYZ to run for 3 months. Could you give it a cost? Because for us, getting capital expense is quite easy. We have a cost estimate done based on number of websites and number of views, and as a research organization, Oxford, we also benefit by the fact that the ingress charges are lesser than what it would be. But on the whole, we have developed not only, I believe we have set up budgeting as well, isn't it, Speed? We get emails
Absolutely.
twice a month or something. That's also there.
Yeah, so yeah, there is a lot we've done, and there's a lot more that we are actively doing together as well in terms of monitoring costs on the site. So there are so many wins and challenges in utilizing the tools that we have, the managed services that we have from AWS. So our biggest cost is probably because we have the Elasticsearch. It's a ongoing cost for that managed service to be available. The fantastic bit about utilizing Lambda is we only pay for what we use when we use it. So the more popular it gets, the more it's used, the more we pay. And there has been challenges in the team to understand the popularity of what the new site will bring, but we have managed to map out a number of options for you to be able to work that through. And yes, ongoing, we we've worked out what normal is now. We understand what normal is, and we are putting in daily thresholds, so anything is alerted to us. And the team can manage that and understand where and why that is, both on a proactive, positive note from increased usage, or in a case of, oh, that didn't quite, that consumed more than we were planning to, and things like that. So there's lots of tools that we've put in place, and it's all centralized around the tools available to us in Amazon itself. So that's really great.
And it's also managed to surface a lot of hidden costs which we used to have on premise. I think that's an important point, because once these are surfaced, it allows for more business planning in terms of saying this is what we need. And we probably, if we built a whole solution on premise, it wouldn't probably have been possible in this current environment of technology. It would have cost us probably 50 to 80% more, but without the scalability it can offer.
And actually, it just, when we're in the development phase, working with you, it played a part in every conversation as well. It kind of like, what's the right tool for the right time? It's kind of, it's easy to overutilize the fantastic set of resources available from Amazon, and it is very much kind of like, no, we're utilizing this for this reason, and that is the reason why this is here. And this is the cost to drive out of it. So all of our documentation kind of had that built into and for you. So it was really cost is almost like part and parcel of our project.
Also,
and our ongoing support.
Sorry, I've just got a parcel. Please carry on.
No, feel free. So I was just wondering, Pete, how would you go about introducing some other university or get into engagement and start leading another project like this?
Yeah, absolutely. So we basically typically work from an initial conversation, scoping out very high level concerns or interests that the university might have in utilizing cloud, the problems they currently have, their current environment and the to-be environment. We have that as a very kind of initial discussion, and then from that we will go away and do some planning and understand some options that could fulfill these very high level plans. But then we like to go into workshops. We like to work with the customer. So typically we'll then interrogate together, and it might even produce a proof of concept within there as well, or indeed a pilot, as we did for Anjanesh. But we very much prefer a more interactive approach where we're working together and building the right solution for our particular customer. And then from that, we will then go into a project phase. We will work in cadence with the project team. We are happy to work within Sprint or Waterfall, though our preference would be to work within Sprint and the building up of those particular bite-sized elements to be able to get those proving and that fast understanding with the customer on whether something worked or not, and then build up the solution accordingly. And as always, these are evolving things, so we'll continue to work with the customer either to support it afterwards in a managed services point of view, which we do for Anjanesh. We support it 24/7 and respond to all those alerts, including having escalations and point to the right teams accordingly. We will invest and integrate ourselves accordingly that best fits that particular workload for that university or customer.
I think on that point, Pete, monitoring was an interesting challenge, because traditionally we can monitor HTTP status code, but here we need to monitor not the page, it'll always come up as okay because it's a Mosaic front end, but we need to monitor how the API gateway is working, whether we can go through. So yes, sorry, please carry on.
Yeah, absolutely. And through testing, we noticed so some of the hidden aspects of utilizing Lambda is the typically you'll know when it's invoked, it'll run and it'll be okay. However, sometimes that invoking time can just take a little bit of time to invoke. It can go cold, which is a known term. So we actually noticed that in testing that a few of the lesser used functions were going cold. So we actually mitigated that right up front, and we actually have logs within the actual Lambda itself to be able to monitor that, and we centralize that back into the cloud for CloudWatch tooling as well to get help that.
Yeah. So jointly we can provide this courtesy onboard program, which would actually enable you to get a snippet or a demo of an engagement with Cyrus HQ, as we see in that example. So what you can get through that experience is a 3 to 5 day workshop where the Cyrus HQ will come in and they will do the scoping. They will completely understand the need. They will deliver a sample, an architecture deployed to the cloud, and you can get actually the experience of how the cloud projects work, what kind of skills you really need to start architecting, and you can also get an insight into 30 days of using that kind of let's say a pilot workload. And you can, as you got from this example, you can continue building on that pilot and quickly go into production and make a usable workload. What is one of the key benefits of going to the cloud? You can experiment. You can at relatively low cost or no cost at whatever. You can build the prototypes, and then you can choose whether to go forward into production or not.
Yeah.
So at this stage, we are almost to the time to the Q&A. So we have some questions from the audience. So what the first question is, what is the thing that worked best, and what, if anything, would you do differently if you started again?
I think we can both answer the same question, but different ways, isn't it? So from a business perspective, what is the thing that worked best is the speed and the assurance and the confidence of the whole process, backed by Amazon. So I have to give credit to our Amazon account manager, Nick Jefferson, Pradi, the Amazon solution architect, the fantastic documentation, Service HQ, the team as such, the planning and the development and the deployment worked best. The introduction of GitHub was innovative in its own. Again, it's not something that I could figure out at the beginning, but there was a whole consultative process which worked. And what would we have done differently? I would preload a lot of skills. I would have set aside, I wouldn't underestimate the skills needed at a high level to get this done. And again, there's plenty of learning resources. And also, I wouldn't underestimate the importance of our internal service desk, because it's crucial that internal teams are aware of how this works, what the triage points are. And that's I think that those are two key fundamentals. Pay attention to the service desk and upskill the team, because we would underestimate how fast things move.
And Pete, any insight from you?
Yeah, so we had had a really nice lessons learned session with the project manager of this particular project, where we were discussing a number of things, and I think we both agreed that actually, in terms of lessons learned, the knowledge transfer up front of key AWS terms, just to be able to hit the ground running and allow for the entire team to have a reassurance on some of the more technical aspects of AWS, because we didn't actually dip our toes in at the shallow end. We went serverless straight in. So we went straight into the deep end with some fantastic appropriate best of practice architecture. And I certainly, on reflection, would certainly like to have done more training and hands-on sessions up front to be able to make the entire team feel comfortable with the experience. On a positive, on the other end, what I'm really proud of is, so from our architecture point of view, is because it's code and automated, from the ground up, we have a reusable architecture that is built on the right building blocks for this particular solution, and it is the right grounds for it. And the speed and agility of which we can now deploy and deliver and update in a consistent manner to give confidence to everybody around us in terms of the approach and the building blocks is absolutely the strength of the DevOps skills that the technical team at Cirrus brought to the table from my point of view.
So we do have another question on security, and this question is: are we using any tools, or are you using any tools for monitoring availability and security, and what kind of tools those are?
So from a business perspective, we monitor for security. We use the fantastic service by National Cyber Security Centers, which is called the WebCheck, which probes websites for usual vulnerabilities and anything else. We also monitor the backend for anything that's the backend on premise to see if anything that's untoward has happened onto the backend, where the data leak has happened. So from my angle, anything that's published to Amazon is public. So that's already in the public domain. But we need to make sure that the data is sanitized before it goes. That's the business process which we keep track of internally. Pete can explain a bit more about the WAF and other bits within Amazon itself.
Yeah, so there are actually a number of tools that we utilized to basically protect and monitor the solutions. So we're utilizing AWS config to ensure that any actions or any anything that's happened inside the actual AWS environment is captured in terms of logging and things like that. So we can absolutely interrogate from a detective point of view anything that's running from there. We also utilizing CloudTrail, so it's helped with the remedial management, so we can interrogate those logs that are generated. So from a performance factor, we're utilizing X-ray to be able to ensure that the lambdas are consistently performing. And then from a WAF point of view, so that's from the ingress and egress points to the actual application, we are aligned to a number of the core AWS built security packages for vulnerabilities at the edge as well, like that. So we have a number of those that we have aligned to that, and they're all on AWS and out the kind of the box solutions for those to manage those points.
Cool, thanks. So we are almost 2 minutes to the top of the hour, and we have a list of questions here, but we will take another one to finish up, which is pretty much aligned with our focus on the customer and being the most customer obsessed company in the world. So what do the user thinks of the improved system? What has the feedback been from the end users?
So, well, the good thing is there's been no feedback because it just works. That's the best part. It just works seamlessly. There is no this is from the end user, is our public website visitor. They don't see the difference in saying that this is a Mosaic site in which the middle bit is coming from collections online triggered by Lambda using Node.js. They don't see any difference. That's the best part. So because if it sets apart as something that's different, that would be something we would really be worried about. Technology, my principle, should be invisible, and it's really worked in this case. Users don't see any fundamental difference in how they're browsing, and from the internal perspective, our collections managers in the past, they need to know how to work with Linux, how to work with process, how to make sure the API calls from one server to the other's work. This is not their core work. So now they're freeing up all their time and the worries to make sure they're focusing on the collections curation and export of data, sanitizing data, and that's the major benefit we see in the business in terms of, and plus from a service aspect, working with ServiceHQ has been really important for us, because the beneficial bit is we get excellent quality documentation that's passed down to us. We get code reviews, we get technical workshops, and we've got quite a lot of feeder projects which is working. We are working on POCs. It sort of builds a foundation to how we develop Amazon and a public cloud strategy. I think that that's the core benefit from the whole project is like, how do we deliver a public cloud strategy? How can we innovative? And something I listen on podcast comes up saying, okay, how do we work with this? We know we can do it. Can we do it? And we discuss bounce ideas around, and the whole the people side of things has been the main benefit. How do we work together? Because it's impossible to keep on top of all the developments.
Cool. So at this stage, we are at the top of the hour, and thanks a lot for attending the webinar. I really do hope that we managed to share some interesting insights. I also wish to thank especially Pete and Anjanesh of doing such a great presentation and sharing the experience. I'm confident that many of the people on the call are appreciative. And I just want to mention that we will make this webinar available on demand. So you will be also informed when the webinar is posted. And then if you have any kind of additional questions or needs, or would like to discuss this further with Cyrus HQ, feel free to reach out to us. So thanks, and hope to see you again soon.
Thank you. Thank you, everyone.